Hey, Eli, I got your email. Good question. Let me show you what happened here and why you're not seeing the fact that this is negative infinity, this limit. So what you've got here, what's missing from what Desmos? Desmos doesn't show vertical asymptotes. That they don't graph them because they're technically not really there. It kind of looks like there's a vertical asymptote here at the origin because there's that's in the window and there's output there, but it's just too vertical, and I'll show you that here in a second. But first, let's do a little bit of analysis here. So the problem is when we're trying to find what's taking place in behavior, change of signs when we can go from positive to negative. They can take place at zeros when the numerator is equal to 0, but they can also take place at asymptotes, vertical asymptotes, when the denominator is equal to 0. So if I set the numerator equal to 0, I end up with 1 plus x, 1 minus x, which means x could be 1 or negative 1, and that's the zeros here if we graphed it with Desmos and zoomed in far enough to see it. You can see you've got them plotted, or Desmos plots them when you did it before. But then the denominator, if we factor that denominator x plus 8, that's where the denominator is equal to 0, and as long as those things don't make the numerator equal to 0, then those things are vertical asymptotes. And so we get a vertical asymptote at x equals 0, which we can tell that was the one I dashed in before. But we also get this vertical asymptote at x equals negative 8, about right here. And the thing is, the graph is, at vertical asymptotes we get sign changes, typically, not always when there's even powers on the outside, but with this even odd power on the outside up here, we typically get sign changes at asymptotes and at zeros. So if you made yourself a little table of the regions that are created by these zeros and these asymptotes, and then a test point, I'm going to just put TP for test point and the region, and then a sign, you'll see that we do get down below the axis on the left side of negative 8. So the regions created by these numbers, this function is continuous everywhere except at those asymptotes, because this is a rational function. So if we start at negative infinity and then go to the first 0 or asymptote we come to, which is negative 8, that's one region. Okay, and then from negative 8 to negative 1 is another region, and then we go from negative 1 to 0, and then 0 to 1, and then finally the last region is 1 to infinity. Alright, so if you pick a test point, that just means any number in that region. So if we picked, let's do negative 9 in that region. In this region, negative 8 to negative 1, let's do negative 2. Alright, and then negative 1 to 0, let's do negative a half. And then 0 to 1, positive a half. And then 1 to infinity, 2. Okay. Alright, now some of them are easy. Some of them you can just eyeball it and see what sign you're going to get. Like, for instance, at 2, right, in that region. So there's where we crossed at 1. So at 2, you can see up here that we're below the axis. So we are below, so the sign would be negative. At 1/2 is not as easy to see, so you can go to a calculator. This is a TI calculator. I've got a function stored in here, and then I can go to the table setup, and I'm going to tell it to ask points. And then I'm going to go to the table, and I'm going to say, plug in a half. Alright, and it gives me 2.5 e to the negative 5, which means it's positive, but it's really, really tiny. So that's positive and a half. Alright, and then if you did negative a half, so negative 0.5, I see I get scientific notation again, but it's negative. So it's negative there, and you can kind of see what's happening. Like we were saying, it just changes signs at every zero or asymptote. So it changed sign right here was an asymptote. So it changed sign. It went from plus on one side and minus on the other. Okay, and then the others are zeros. Right, so we were positive, we're headed towards positive infinity on the right side of 0, negative infinity on the left side of 0. And then if you look at negative 2, if I plug that in there, that test point in that region, that's a positive 4, so again we're positive. Alright, so you can see that pattern of alternating between positive, negative, continues. It's never guaranteed to do that, but it's looking like it will change that way depending on your signs. It's the powers out here that could create two things going off to positive infinity. But if you were to look at negative 9, if you type that in there, it's negative, but it's huge negative. It gets really big because these numbers, if you think about them, negative 9, when it goes in there, that becomes an 81. That's a 72, but this number becomes huge, when we're talking about that. And then we're taking a huge number, dividing it by a not as huge number, so it's still big, and then we're raising it to the 7th power. So to get Desmos, if you're wanting to show it that, to show on this other side, you're like, hey, it looks like it's going up to positive infinity. Well, get negative 8 in the window, where that other asymptote is. Alright, and now you'll need to change your Y scale to go way, 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 way down below. Like negative, let's do negative 2, I think it's E on Desmos. I'll just add a bunch of zeros and see if we can get it to show up. There it comes. So it's way, way, way on down there. Alright, but if we make these numbers big enough in the negative direction, we can finally get that in behavior that we're supposed to get. So it's just, you were looking in a window that was like, right here. And this is what you were seeing. But we needed to go here, actually kind of looking like right in there. But we weren't getting the right end behavior. You were getting it on this side. Oh, that's still at the 0. But you weren't getting on the left side because we didn't go down far enough. Notice that little relative max right there is at negative 2.807 times 10 to the 18th. So a negative 2 with 0.807 with 15 more zeros out beside it, and this number right here was negative 10 on yours. So we were just too zoomed in to be able to get all the characteristics of the graph, and that was the reason why you didn't see that left end behavior.